Hello everyone, welcome back again to my channel. Now in this video, we're going to be understanding the overall architecture of Kubernetes. Sometimes when people don't understand the architecture of how the Kubernetes the various part works, it becomes very difficult for you to troubleshoot some of the issues that you're going to be facing as a Kubernetes administrator. So before even learning the workload, deployment pods, those kind of little things that works within the cluster, it is advisable that you understand the overall architecture of how Kubernetes actually works. And that is why in this video, we're going to be, touching some of these components. We're going to be understanding their roles and functions and why we need them within a Kubernetes environment. If this sounds interesting and it's something that you want to look forward to, please keep watching till the end. And don't forget to hit the subscribe button to get notified whenever new video are uploaded. Without wasting much of your time, let's jump straight into it. Now let's understand the architecture of Kubernetes. Now, first of all, what are you going to learn from this video? Now we're going to understand the two major classifications of the nodes within the cluster. We're going to understand what the master node is, what the control plane is, and their components. We're going to understand the worker node and their components, and also we're also going to understand how it all fits together. We're also going to learn the various ways of deploying Kubernetes in a production environment or even in a testing environment. Now, let's understand the Kubernetes architecture. Now, the Kubernetes architecture at a basic level comprises of different servers or different machines. Now, have you ever wondered why we call it a cluster? Now, by default, what is a cluster? A cluster is just like a collection of different resources, right, combined together to form a cluster. And that is why we call it a Kubernetes cluster. A Kubernetes cluster comprises of various Linux machines or various servers coming together to form a cluster. Now, if you have 2 laptops or even 3 machines, right, those 3 machines can be used to create a cluster. Now, a cluster comprises of nodes, right? It comprises of various nodes, and those nodes can be grouped into 2 major categories. We have the master nodes and the worker nodes. Now, the master node are also regarded to as a control plane, right? While the worker nodes can also be called a data plane or the worker nodes. They are the nodes that are actually responsible for running your workload. Whenever you deploy an application to a Kubernetes environment, those applications are be scheduled and be deployed on those worker nodes. Now, from this high-level overview, you're going to see some of the components that makes up the overall architecture of Kubernetes. Now, if you go to the Kubernetes documentation, you're going to see this. You're going to see the various components, and this is a well-detailed, not a well-detailed diagram, but it gives you an idea of how it looks like. Right, in this diagram, you can see we have 3 worker nodes, 1, 2, 3. These are the 3 worker nodes. And also we also have the control plane, which is on the left-hand side. And the control plane comprises of different components, right? You can see them here. And you can see that each of the components communicate with a central one, which is called the API server. And then we also have the cloud provider API that your Kubernetes component can also communicate with. But this is just like the various components, and let's understand each of these components in much more detail. Now, at the center of the control plane, we have all these components. We have the first one, which is the Kube API server. Now, what is the Kube API server? Now, the Kube API server is the entrance, is the entry point into your cluster. Now, sometimes when people say the master node or the control plane, they're actually referring to the Kube API server, because this is the main entry, right? It is the front door into your cluster. Now, whenever you want to create any pods, you want to do anything in your cluster, that request needs to go through the Kube API server. right? So think of it as the main entrance into your cluster, because your cluster is, is abstracted, or it is demarcated that nothing external goes in without being authenticated through the API server. And the second one we have there is your etcd. Now, your etcd is a key value pair store, or a database that stores the information about your cluster. Now, without the etcd, if something happens to your cluster, there's no way for you to, get back your cluster, and there's no way for your cluster to keep its state. Now, I need you to understand that Kubernetes works with in a declarative pattern. When I mean declarative, you specify what you want, and then you tell Kubernetes that this is what you want. Now, what Kubernetes does is that whatever you specify is your desired state, right? And whatever you have inside your cluster is called your current state. Now, what Kubernetes does is that it brings your desired state to what? It brings your desired state to the current state. Now, how does Kubernetes does that is with the etcd, because the etcd keeps the current state of your cluster. Why? Your desired state is what you are asking Kubernetes to do for you. So if there's no way for Kubernetes to store your current state, then whatever you give Kubernetes is just, run it directly in your cluster. So your etcd is very important. It is the brain. It is the database. I call it the database that stores all your information within your cluster. And also, we also have the kube scheduler. Now, the kube scheduler is a very, very important and vital component within your control plane. Now, the kube scheduler is in charge of placing pods on nodes. Remember that the Kubernetes cluster comprises of more than one node. We have different nodes spread across different machines, right? And then, whenever you want to deploy a pod, how does Kubernetes know which node to run that pod on? And that is what the kube scheduler does. Now, the kube scheduler makes some intelligent decision based on the requirement. Now, if you specify your pod to have a certain number of CPUs, RAMs, or memory, now the kube scheduler goes through all the nodes and find a suitable one that can accommodate your pod. Now, it finds that node rather, and then assign your pod to that node. So it's a very vital component. And also, we also have the controller manager. Now, remember I made mention of the desired state and the current state. Now, your scheduler is in charge of that reconciliation loop that brings your desired state to your current state, or your current state to the desired state, whichever one that makes more sense to you. So that's what the controller manager does. It's in charge of going through the cluster. It's just like an ever. It is just like a never-ending loops that compares your desired state to your current state, and then see if there's any discrepancy, and then tries to bring your current state to your desired state, because desired state is what you want in your cluster, and that is what the controller manager does. It goes through everything to make sure that everything is in place. Now, you need to understand that the controller manager always compare what you have on your etcd to what you actually have in your cluster. Now, let me give you a very basic example. Now, let's say that you deploy an application and you specify that you need 3 replicas of that application to run, right? This is what you specified on your Kubernetes manifest, and that is what is being stored in etcd. So what the kube scheduler does is that it says that on the etcd, you specify 3 replicas of your application, whereas in your actual environment, maybe somebody manually deletes one of the replicas. You now have 2 replicas. Now, what happens is that the controller manager is going to see that you specify 3 replicas of your application. You specify 3 replicas of your application, but you currently have just 2. So what it does is that it brings up another one to ensure that your current state matches the desired state, and that is just one of the things that controller manager does. This is just to give you an idea of the importance of controller manager. We also have the cloud controller Manager, CCM. Now, this is optional if you are deploying a vanilla Kubernetes, but if you are deploying to the cloud, most of these components, the cloud controller manager is being handled by your cloud provider. And this is how your Kubernetes communicate with your cloud provider. For instance, if you want to deploy a load balancer within Kubernetes, and you have your cloud controller manager installed, this is the cloud controller manager is going to interact with your cloud provider API and then provision those load balancer. Now let's have a look at the worker node. Now the worker node is what actually runs the workload, right? They are in charge of running the main workloads within your cluster. And also, they also have 3 other components like the kubelet, the container runtime, and the kubeproxy. Now, I need you to understand that all of these components, the kubelet, the container runtime, and the kubeproxy, are not just the worker node processes. They also run across the entire cluster. But for simplicity, I decided to just split it into these two like this to make you understand the overall architecture of Kubernetes. But I just needed to pay attention. Now, the kubelet is an agent that runs on all the nodes within the cluster. So if you have 10 nodes, 10 servers in your cluster, kubelet must run on each of those nodes. Now, what kubelet does is that it is the agent that pulls information from this node to the kube API server. Remember, I told you that the kube API server is in charge, is the main brain, it coordinates the entire cluster, right? When we refer to the control plane, we are actually referring to the kube API server. Now, this kubelet runs on each of those nodes and pulls information from those nodes to the kube API server. Because without the kubelet, there's no way for the kube API server to oversee all the information or all the processes that are running on those nodes. So that is what the kubelet does. So it goes into those nodes, rather it stays on those nodes and sends information and status back to the kube API server. We also have the container runtime. Now, the container runtime is in charge of running the containers. Remember that your pod houses a container, and those containers needs to run somewhere. Now, those containers are being managed under the hood by this container runtime. So the kubelet, is in charge of communicating with the container runtime to run those containers. And once those containers has been spawned and has been once those container has been deployed and once those container has been run by the container runtime, the kubelet gets those information and sends it back to the kube API server. And that is where you as a user, you cannot say that your pods are running, because you are getting information from the container runtime to the kubelet and from the kubelet back to the kube API server. We also have a last component called the kubeproxy. Now, the kubeproxy is an agent that runs as a daemon set across all nodes. Now, what the kubeproxy does is that it forwards traffic from pods to service and from service to pod. So this is the main function. Don't worry if you don't understand that. We're going to go into detail in the upcoming videos. Now, I need you to understand, just like I've said before, that all nodes must contain a kubelet, a kubeproxy, and a container runtime. Now, let's talk about some of the add-ons. Now, the first add-on we want to talk about is DNS. Now, within your cluster, you need DNS to resolve service, to resolve name to an IP address. And because of that, you need to install DNS in your cluster. Don't worry if you are using this, if you are deploying this by yourself using kubeadm or even the cloud, this is already taken care of by you. But I just need to point that out to you that DNS is very important. And secondly is CNI. Now, this is up to you to choose whatever CNI plugin that you want to use, right? We have different solutions for CNI. CNI stands for Container Network Interface. It is how your pod get assigned an IP address. Now, you need to understand that without CNI in your cluster, your pod will not run because they can't get the IP address. So your CNI is just like the network interface within your cluster that help your pod to communicate with each other. So we have Cilium, which is one of the best CNI plugins out there that uses eBPF. We also have WeaveNet, which is another good solution. And also we also have the last one, which is Calico. And also we also have Container CSI, which is Container Storage Interface. Now you need a mechanism to store your information, to store data within your cluster. Now if you are running a stateful application like database, you need to be able to store your data, and you need a plugin, and that is where the CSI, driver, or the CSI plugin or CSI add-on comes in. We have Ruxef, which is a managed or an open source solution. We have AWS, EBS, and also different cloud providers have their own CSI. But if you are running a bare metal setup of Kubernetes, Ruxef is the go-to choice. We also have monitoring and logging. You should be able to monitor your application running in your cluster. You need to be able to see the overall health of your nodes, because your nodes are servers. So you need to monitor them to gather metrics like CPU utilization, memory utilization, disk utilization, your network traffic, those kind of little things. You need to be able to monitor them. And you also need to collect logs from your applications, because containers are ephemeral. They're just like your pods, right? So when they die, everything is gone. So if something happens to your pod and it keeps getting restarted, it's being killed, and you are not getting the information that you need, it becomes very difficult for you to troubleshoot. But with logging, even before the application dies, that logs has already been collected by an agent, and you can then query those logs to see what actually went wrong and what actually happened within your cluster. We also have the Kubernetes dashboard that helps you to visualize your cluster at a glance for you to see how your cluster is doing, right? And I kind of find this fulfilling because you get to see your cluster, everything within your cluster, right? It's really nice. Now, how does all of them fit together? Now, let's understand how the pod request by a user goes through all these phases and then getting status back that pod has been created. Now, let's start with the first one, which is the client. Now, you as a client, you want to create a pod. Now, a pod in Kubernetes is your application that you want to create. Now, what happens is that the client needs to communicate with the API server. Now, the Kube API server needs to authenticate the client and make sure that that client is have all the necessary credentials to authenticate. Then after that, that client needs to be authorized as well. So once everything is done, the client is authenticated, it is authorized. Now, that pod creation, the object definition of that pod, all the information regarding that pod is stored in the etcd. Now, like I said, the etcd stores information about the cluster. Now, once those information has been stored inside the etcd, the controller manager, like I said, sees that the etcd needs, the controller manager compares the state in the etcd and it sees that there's a pod that needs to be created, which is not in the cluster. So the controller manager now creates that pod resources and updates the etcd, right? It supplies the etcd with some metadata, and then the Kube scheduler sees that, right? And once the Kube scheduler sees that there's a pod that needs to be created and that pod needs to be assigned to a node, it extracts all the metadata, right? All the information, and use it to make an informed decision on where to place the pod. So the Kube scheduler goes through all the nodes and find a suitable one that matches that criteria and then place that pod on that node. Now, the Kube scheduler sees that a pod has been assigned to its node, and then it receives the template of that pod from the Kube API server and then communicate with the container runtime, which is Docker, it could be containerd, it could be CRIO. It communicates with that container runtime to run the application. Now, the container runtime pulls the image and, starts the container, do everything possible for the container to be in a running state. And once the container is running, the kubelet is sends and it sends the status back to the kubelet. Now the kubelet gathers this information from the container runtime and then sends it back to the kube API server. And you as a user, you can see this by running kubectl get pod. Now when you run kubectl get pod, you can now see the information about your pod, and all this information are being reported from the container runtime to the kubelet and back to you as a client. So this is just like the overall journey of how you can create a pod or any resources in a Kubernetes environment. Now, what are the various ways to deploy Kubernetes? Now, we have a local setup, right? And this is not advisable for a production environment. You can use Minikube, Kind, Docker, or Docker desktop to deploy your Kubernetes cluster. We also have managed solution, which is the main one, which is the industry standard for running Kubernetes. We have the popular one, EKS. We have AKS. We have GKE. All these are like managed solution for running a Kubernetes cluster. Also, we also have kubeadm setup, which is the vanilla Kubernetes. And this is quite used often when you are operating like a bare metal Kubernetes cluster. You go with kubeadm or any other management tool that helps you to bootstrap Kubernetes cluster, right? Yeah, so that's it. And we also have K3s as well, that helps to provision cluster, but I really find kubeadm useful. Yeah. So what next after this video? Now, in the upcoming video, we're going to be understanding how we can create a Kubernetes cluster using kubeadm. So thank you so much for sticking around to the end of this video. Please, if you find this video useful, please subscribe to my channel so you can get notified whenever such videos like this are being published. Thank you so much, and I will see you in the next one. Bye-bye.